Okay, welcome to the Chapter 4 kind of review and preview lesson, which is just some of those basic skills we need to remember from a while ago. One of them is interval notation, and the way that we write that is we write the variable that we're talking about with a colon, and then we use a square bracket with the lower bound. The square bracket is only when it's greater than or equal to the lower bound, and then the upper bound is always written second. And I'll put that round bracket here. So if we talk about this in the context of inequalities, this would be saying that whatever variable I'm talking about, I'll just use x here, would be greater than or equal to the lower bound, but less than the upper bound. And we'll talk about this a lot more, and we'll describe this. We're going to do it a couple different ways with a set description, which is inequalities, and then an illustration, which will be a number line. So if we look at the interval that x exists between a and b, then with set notation, I would say in these wonderful brackets that are so fun to write, that x has the conditions that it is greater than a, but less than b. And if I write that as an inequality, or sorry, if I draw that on the number line, we would have to have a point, which we would label as a point which we label as b, and then it would be open dots, and everything between those open dots shaded in. When we have the next one, I'm going to write just the inequalities for now. This set description, this should be present in all of them, but just to save myself a little bit of space, I'm not going to include it. So the second piece, when x is in between a and b with the square brackets, really importantly, that all that does is it requires us to say that x is greater than or equal to a and less than or equal to b. Now on the number line, what that is going to do for us is it is going to switch those open dots to closed dots, or this, to indicate that it's inclusive as well. It can actually be A and B. For the rest of these, it is just important to recognize where that closed bracket is on. This would be that x is greater than or equal to A, but less than B. So the closed dot would be on A, and the open dot would be on B. In this situation, it's almost maybe not the reverse, but kind of the converse of that, that x is greater than A, but less than or equal to B. So the closed dot would be on B, the open dot would be on A, and we would shade that in. From A to infinity, so we would only have to say that x is greater than A. On that number line then, we would have an open dot at A, and everything to the right would be shaded in. So every single number on that number line, above A or greater than A would be valid. This is x is greater than or equal to A. All that does is change my open dot to a closed dot, and still shading everything in to the right of it. Just going to scroll down a little bit, extend that page so I can see it a bit better. From negative infinity to b, that is saying that x must be less than b. So we would have an open dot on b, and everything to the left would be shaded in. This is that, or the next one is x is less than or equal to b. So a closed dot on b, and everything to the left of it shaded in. And then finally, this last from negative infinity to positive infinity, x is an element of the real, and the entire number line will be shaded in. All right, to see what a couple of those look like, just specifically, I would recommend that you try these two questions, and then you can pause the video. Obviously, I'm going to put the solutions up right away, just trying to talk a little bit so that you have the opportunity to pause it without seeing the answer. Now, it really should have the variable in here, and it's not ideal, so I'm going to write that in underneath, that x exists between -2 and 5, and over here, x exists between 3 and infinity. This in set notation, or in inequality, sorry, in terms of inequalities, this would be that x is greater than or equal to -2 and less than 5. I do want to point out that this is also acceptable. If you said that x is less than 5 and greater than or equal to -2, those are saying the same things, which is part of why inequalities are, in my opinion, a little bit worse than interval notation. If I put that on a number line, -2 would be down here, +5 would be somewhere on there. We would have an open dot on +5 and a closed dot on -2. And then we could shade everything in between those values. All right, on the right-hand side, this is just saying that x is greater than 3. So on that number line, at +3, oops, that's a weird 3 there, sorry about that. What we would have is an open dot, and we would shade everything to the right of it. Very importantly, that open dot is indicating, just like when we learned in limits, that it can be everything up to that point, like 2.99999, but it cannot actually be 3 itself.